All right, so again, those are the answers from last night's homework. Are there any questions that you'd like me to do from this one? Yes. 10? All right, so on number 10, we had a right triangle. This is in the section that says use Pythagorean triples to find x. So if we're using Pythagorean triples, we can use one of those triples from yesterday. So we had our 3, 4, 5, our 5, 12, 13, 8, 15, 17. Again, there's a few that I had you write down that come in handy a lot. Those top two were probably the most useful, but there were some here from the other ones as well. Number, you said 10, right? Number 10, we had 25 and 65 there. We were missing that longer leg. Well, look first at the two numbers. Do they share anything in common? They have a common factor of 5. So 25 is 5 times 5. 65 would be 13 times 5. So whatever this leg is, it's going to be a multiple of 5. But we have 5 blank 13. Well, the one that goes with this is 5, 12, 13. That's the middle number that's missing. So 12 times 5 is 60. Yeah, that's how we can use those triples in order to solve instead of doing all the Pythagorean theorem. Now, could we have done Pythagorean theorem? Yeah, again, Pythagorean theorem works there, but again, triples are supposed to help us make this easier and find them faster. Any others from this page that you'd like me to do? 16? All right, so 16 was down here under the part where we're saying you had to first classify whether it was a triangle. So again, you had to look at if you add together the two smallest values, would it be greater than the third side? This one might have been hard to tell at first, but the square root of 7 is definitely more than 1. This is definitely more than 3. So even if I said 1 plus 3, that would equal 4. I know that they're more than that. So even if you didn't solve them out completely, that's fine. We know it definitely makes a triangle because those two had to be greater than the third side. As far as how do we tell if it's acute obtuse or not, we are going to take, again, these 3 values and plug them into Pythagorean theorem. We're going to take the longest side and plug it in for our C value. Now, that's the part that might be tricky here, because which one is the longest side? It's either 2 radical 3 or 4, and I'm not sure. You're actually going to have to plug it into a calculator probably to figure that one out. 2 radical 3 simplifies down, I think, to like 1 point, I don't know, 1 point something, 1.2, 1.3, somewhere in there. So it's going to be close. Does somebody have a calculator that can do square root 2? Square root 2 on the calculator. See so many phones out. Somebody should be able to switch over to a calculator. Tell me. Square root 2 is? That's more than 1. What'd you get? 1 point something. 1.4. All right, so if it's 1.4, now take that and multiply by 3, because I think that's going to be greater than 4. So, right, if you take that number you got, now times it by 3, what do you actually get? 4.2. So this value is actually the bigger value. And that's something that could have thrown your work off, because which one goes into the C value is the largest one. So that one is kind of tricky because the C value there is the 3 radical 2. And then those other 2 go in for 2 legs. So we still walk through, we square the parts that we need. On here, that's 9 and 2. On here, that's just going to be 7. On here, that's 4. 4 squared is 16. So again, squaring this one, you got to square both parts. So remember your rules from exponents back in Algebra 1. That exponent is distributed to both values. So that's why we got the 9 and the 2. So now we have 18. On this side, whoops, that was a plus sign, not a multiple. 7 plus 16 is 23. So it's not equal to, it's actually going to be a less than symbol there, which makes this a cube. And again, that was the answer to number 16. If you had plugged it in the order that it appeared there and thought that 4 was the biggest one, you probably would have gotten 2s instead of a cube, which would have thrown you off. All right. The biggest side was the 3 radical 2. Any other questions on that? Or any other? All right. Well, then let's move on to the sheet that I gave you already. Clear this. Let's see that. So, all right. The next thing that we're going to do, special right triangles. Now, I wrote a lot of information on the board over there. I'm going to rewrite it on here because, again, I want to make sure that I get recorded so that I can post it so that everybody that is out is able to get it as well. But we have a special right triangle. That's what we're going to be talking about today. Special right triangles. We have 45, 45, 90, and 30, 60, 90. Those names are based on the actual angle measures. So on this image, and I'm going to redraw it here, but on that image, that is a 45, 45, 90. All right. 45, 45, 90 refers to the measurements in that triangle. So this is a 45-degree angle, a 45-degree angle, and 90-degree angle. Now, there are certain things that you know right away. Since we have 2 angles that are congruent, what does that mean about a side? We have 2 congruent sides as well. So across from them, these 2 have to be congruent. Because one of our properties early on from the year was, actually there's 2 different properties we could look at. One was the converse of isosceles triangle, which said if you had 2 congruent angles, then the sides opposite them were congruent. Or you could look at the other property that said the sides and angles correspond, so that the smallest angles across the small side, biggest angles across the big side, well, if they're the same size. So on here, those 2 are congruent. And normally we're going to refer to those 2 as X. That's going to be a starting spot. Now, I know this diagram already shows you that the other side is x squared of 2. Well, how do you actually get there? We have Pythagorean theorem. We know 2 sides. So we can say x squared plus x squared equals our unknown side squared. All right, that's using Pythagorean theorem. Well, if we add these 2 together, that gives us 2x squared. We want c by itself, so we square root it. On this side, well, square root of 2, that's still going to stay square root of 2, but square root of x squared, well, x squared, that can cancel out and come outside. We get x radical 2. And that's how we're able to say this hypotenuse is x squared root of 2. So our legs will always be congruent. Our hypotenuse will always be our leg times the square root of 2. So on here, we're going to do a couple examples. Now, the first one that we have, all right, I'm going to jump around in a different order than what they have here, but I'm going to start with the first one. The first one we have in the same exact positioning as this. We have the bottom value is 8. So we know that the other leg is also 8. Where x is, again, using this property, well, whatever these 2 legs are, the hypotenuse is the leg times square root of 2. So this is 8 and that's 8. This is what? Plug it in. So plug in 8 here for our x's, plug in 8 there, we get 8 square root of 2. That's our answer. That's it. Done with that problem. Let's look at another one. So go over there to number 3. Same thing, it's just flipped around. On number 3, they give us that this one leg is 4. All right. So that means that our other leg is 4. And then the hypotenuse, which is now the bottom, is going to be what? 4 radical 2. Again, it's just following that pattern. There's something, if you memorize that pattern, there's not really any work to do there. All right. The next one that I want to take a look at, let's look at 5. So instead of giving us the legs, they gave us the, oh, actually, no, not that one. All right, just kidding. I want to do 6 next. Yeah. On 6, we have the hypotenuse given to us. We have 24 radical 2, so the legs would then just be 24. Backwards, we took off that radical, and now we have just 24 for our legs. Same thing on number 2. It's facing a different direction, but we have the hypotenuse given to us. It's 3 radical 2, so the legs are both what? 3. Now, 4 and 5 are a little bit tricky. All right. Let's start with 5. All right. Where we're giving our value, it's our hypotenuse. But normally our hypotenuse has what on it? It normally has a radical. Does this have a radical? No. So we're still going backwards. We still got to get rid of the radical. Just like we got rid of the radical on number 2 and number 6. Right? How did we get rid of the radical? Well, this was 3 times square root of 2 on number 2, right? So what's the opposite of multiplying? Dividing. That's how we technically got rid of the square root of 2. Divided off square root of 2. Just like on the first one, we multiplied by square root of 2. If we went backwards, we divided by square root of 2. Same thing for number 5. We're going to have to divide by square root of 2. So for x value here, we have 16 divided by square root of 2. Now, you cannot leave a radical on a denominator. So first I'm going to show you a shortcut. What's going to happen here, each and every time you divide by a square root, you're going to divide by whatever numbers in the radical. So 16 divided by 2 in this case is 8. Then we're going to multiply by the same radical. So this ends up being 8 radical 2. And that's our answer for both of these sides. 8 radical 2. Now, there's a pattern there that will always hold true. Whatever you're dividing by, you're going to divide by what's underneath the radical and then multiply by the same radical. And I'm going to show you why that is now. So we have, I'm going to start off with here. 16 radical 2, right? In algebra, you talk about something called rationalizing a denominator. Whether you remember or not, whenever you did radicals, you did rationalizing a denominator. You can't leave a radical in your denominator. So we rationalize. To get rid of that radical, we are going to have to do something that would be the opposite of taking a square root to get rid of it. What's the opposite of taking a square root? Squaring. Yeah. So we're squaring. So how do you actually square a number? You multiply it by itself. So on here, we are multiplying that denominator by square root of 2. Well, I can't just randomly multiply things by square root of 2 on just one part of this, because that changes the value. So if I multiply something on the bottom, got to do it to the top as well. Because now, instead of multiplying just the bottom by a random radical 2, this is like I'm multiplying by the value of 1. So I'm not actually changing the value of 1. Ooh, I just realized that quick. That should have been a multiplication symbol. All right. So what do we actually have? That's 16 radical 2 on top. On bottom, square root of 2 times square root of 2, that's going to be square root of 4, or better yet, just to show why we did that, I could say that this is the square root of 2 squared, because that was the whole point, right? We're trying to get rid of our radical. It cancels out, leaves us just 2 on the bottom. So now we have a 2 on the bottom, we have 16 radical 2 on top. What happens? 16 divided by 2 is 8. We get 8 radical 2. That's our answer. Now, do we have to do all that work every single time? No, because it's the same pattern every single time. It's just like using our formula that we did here. We have these. So do I have to go back and do all this work every single time? No. We have a pattern anytime you divide by a radical, you can divide by the number that's underneath the radical and multiply by the same radical. You don't have to show that work every single time. So on number 4, I have 18. Same idea. I need to go backwards and divide by the radical. So divide 18 by radical 2. What would you get? 9 radical 2. You don't have to show any more work there. That's our answer. Divide by a radical, divide by the number under the radical. So 18 divided by 2 is 9. Multiply by the same radical, square root of 2. All right. Let's go to the other page. Again, same side of your paper. Can I clear this and get rid of it? Again, a lot of my work I do have over there on the sideboard. I did it last class. I'm going to leave a lot of this stuff up, just like I've been leaving this up all week. I'm going to leave that top part over there up all week as well. Here. All right. Moving on. So now we are looking at our 30, 60, 90s. Now this time they did not draw that completely the way I like it. So I'm going to redraw that one. I'm going to redraw it right there. So on this one, you have a 3069. Again, it's called that because of its angle measures. 30, 60, 90, because we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. There's a pattern for this one as well. Now, the pattern here is easiestly explained if I actually start off, instead of a 30, 60, 90, I'm going to start with an equilateral triangle. So in an equilateral triangle, every single one of my angles is 60, right? Including that top angle. I'm going to draw the height to it. So instead of saying that whole thing is 60, each of these is now 30. Right? Well, I split this in half when I do that in there. So starting with this smallest piece, I know that those are x, which means that the entire side of this is 2x. And this side's 2x, these sides are 2x. All right. Now, I have a right triangle in there. I can find that missing piece. All right. Let me go ahead and label this figure over here too. So I have x for my short leg, and I have 2x for what's acting as my hypotenuse. All right. Now, I'm missing that long leg. Well, I can use Pythagorean theorem again. I already know my C value is going to be the 2x. The other two legs, one of them is x, one of them I don't know. I'm just going to call it b. Plug it in Pythagorean theorem. Square this. Again, you're squaring both of those values, so this becomes 4x squared. Bringing the x squared over from the one side by subtracting it, we're now left with 3x squared. We got to get rid of the square, so we're going to square root. And that other missing side is now, well, x squared. We can cancel off the square and take it out of our radical. The 3 is not a perfect square, so it stays in. So that missing side is x radical 3. Now, I would highly recommend labeling as well those parts, because I will refer to them often as our hypotenuse, our short leg, and our long leg. All right.
Please pardon this interruption. The Ronnie Velasquez Morales, please report to the main office. The Ronnie Velasquez Morales, please report to the main office.
All right. So yeah, down here, we're kind of doing the same thing that we did on the last set. Right? We're using these properties. We're not going to have to do all this mess ever again. All right. And I'll leave that top part on the board over there so you have it to reference. But We're gonna go through some of these. Now, I'm gonna go in order to make this easy. We're gonna start with number 2. Number 2, we have a 60-degree angle. Now, they don't tell us this angle, but what do we know it has to be? So this is the right angle, 60-degree angle. That one has to be a 30-degree angle. All right. Now, what piece do they give us? The long leg, the short leg, or the hypotenuse? Well, in a triangle, the longest side is across from the biggest angle. The shortest side is across from the smallest angle. So the short leg is always across from the 30-degree angle. So this is our short leg. And everything is based off that short leg. So if I know that that's 8, what's my hypotenuse? So why we got my hypotenuse and what's the value of it? So if this is 8, I got to double it. And my hypotenuse is 16. So y value here, 16. Now, if I went for the long leg, all right, so the long leg, I'm taking that 8 and I'm multiplying by square root of 3. So this is 8 square root of 3. And those are my answers. Next, let's go down to number 6. This time they gave me the hypotenuse first. I gotta go backwards. I know the hypotenuse compared to the short leg is double. So if that's 20, then this piece has to be 10. Yeah, good, thank you. Then for the bottom one, the long leg, I take the short leg and multiply it by square root of 3. So this is 10 radical 3. Yeah, we're just following that same pattern every single time. Let's go over to number 4. On number 4, they gave us the long leg this time. There's the radical there, right? We have 9 radical 3 for the long leg. I need to go backwards and find my short leg. What's the short leg going to be? It's 9. And then the hypotenuse, well, I got to double the short leg, so that's 18. Yeah, each time you're following that same pattern. Now, even with number 1, you're still following the same pattern. We have the short leg is 1/2. If you double 1/2, what do you get? 1. So the hypotenuse is 1. The long leg, I can write this a few different ways. It's 1/2 times square root of 3. Or the simplest form would actually be if I just multiply that to my numerator. I could also write this as square root of 3 over 2. But both of those are accepted. The last two, number 5 and number 3. These two are a little bit special because they're similar to what we did on the other one when we went backwards. All right. We have, actually, let's do 3 first. 3 doesn't make us do anything special with the radicals yet. On 3, we have our hypotenuse. It is not an even number this time. So what's going to happen? Well, when I divide it in half, I get a decimal. So I can either say that this is 11 over 2, which is good for an answer, or 5.5. The other one, this side, we are going to have to take whatever number's here and multiply by radical 3. So if I do the fraction of radical 3, I can say 11 radical 3 over 2. So it's kind of messy, but it works. Or I can do the 5.5 times square root of 3. Either one is fine. So the answers work. Number 5, this is the one that we have a number that's in a position that normally has a radical. So just like we did on the other one, where we had to divide by square root of 2 and then simplify, that same pattern works here. Here, we're going backwards by dividing by radical 3. So if we divide by square root of 3, what's 12 divided by 3? So we're going to have 4, and then multiply by the same radical. It's 4 square root of 3. Once you know your short leg, the hypotenuse is just going to be double that. So times that front number by 2, and you get 8 square root of 3. Again, that one's a little bit different. but it's the same idea as the others. We're dividing by the radical, so when we divide off the radical, we divide by that number that's under the radical and multiply by the same radical. All right, the actual assignment for this will be the next page, which is page, oh, I erased it. What's the next page, 20? So page 20, numbers 1 through 16, so that whole page, all right? So I'm not having you do the second page, just that one. But I gave you an example of each type of problem that you could encounter. Any questions? You want to still go? You can go. Any other questions?